Hello, dear friends. I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by the esteemed Baba Jalani Bomani Dambe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished instructor Baba Jalani Bomani Dambe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the potentiometer. A potentiometer, also known simply as a pot, is a fundamental component in the world of electronics. It is a variable resistor that is used to control electrical resistance in a circuit manually. Potentiometers are widely employed in electronic devices and systems to adjust various parameters such as voltage, current, and signal levels. They are versatile components that offer a simple and effective means of manual control in electronic circuits. The basic structure of a potentiometer consists of a resistive element connected to a movable wiper. As the control knob or slider of the potentiometer is adjusted, the wiper moves along the resistive element, creating an adjustable voltage divider. By varying the position of the wiper relative to the ends of the resistive element, the resistance between the wiper and the ends can be changed. This, in turn, alters the output voltage or current in the circuit, allowing for precise control over the electrical parameters. Potentiometers find applications in various electronic systems and devices. One common use of potentiometers is in volume control circuits, where they are used to adjust the audio output level. They are also used in lighting systems for dimming lights, in motor control circuits for setting the speed of motors, and in display systems for adjusting the brightness of displays. Potentiometers are versatile components that can be found in a wide range of electronic products, from audio equipment and amplifiers to lighting systems and industrial machinery. There are different types of potentiometers available to suit different applications. Linear potentiometers, also known as linear taper potentiometers, provide a linear relationship between the rotation of the control knob and the change in resistance. These potentiometers are commonly used for applications where a linear adjustment is required, such as in audio volume controls. On the other hand, logarithmic potentiometers, also known as audio taper potentiometers, are used in audio applications where a logarithmic relationship between the rotation of the knob and the change in resistance is desired, mimicking the logarithmic response of human hearing. When selecting a potentiometer for a particular application, several key parameters need to be considered. These include the resistance value of the potentiometer, which determines the range of resistance that can be adjusted, the power rating, which specifies the maximum power that the potentiometer can handle, and the taper, which determines the relationship between the rotation of the knob and the change in resistance. By choosing the right potentiometer based on these parameters, designers can ensure that the potentiometer performs optimally in the intended application. Potentiometers are essential components in electronic circuits, providing a simple and effective means of manual control over electrical parameters. With their adjustable resistive element and movable wiper, potentiometers offer a versatile way to adjust voltage, current, and signal levels in electronic systems. Whether used for volume control, lighting dimming, motor speed adjustment, or display brightness adjustment, potentiometers play a crucial role in a wide range of electronic devices and systems. By understanding the different types and parameters of potentiometers, designers can select the most suitable potentiometer for their specific application, ensuring optimal performance and functionality. Volume controls in audio equipment are critical for controlling the sound level of devices, such as radios, amplifiers, and televisions. These controls allow users to adjust the volume to their desired level, whether they are listening to music, watching TV, or amplifying sound for a large audience. Volume controls work by adjusting the signal level of the audio input, which ultimately controls the level of sound output. Dimmer switches, on the other hand, are used for controlling the brightness of lights. These switches provide a convenient way to adjust the lighting in a room to create the desired ambience or mood. Dimmer switches work by regulating the flow of electricity to the light source, thereby controlling the intensity of the light emitted. Speed controls are commonly found in motors and fans, allowing users to adjust the speed at which these devices operate. This is particularly useful in applications where precise control over the speed of rotation is necessary, such as in industrial processes or HVAC systems. Speed controls work by adjusting the voltage or frequency of the power supplied to the motor or fan, thereby controlling the rotational speed. Tuning controls are essential in radios and tuners for selecting specific frequencies or channels. These controls allow users to tune into different radio stations or TV channels with precision. Tuning controls work by adjusting the frequency of the oscillator in the radio or tuner, which determines the frequency to which the device is tuned. Adjustment of output voltage in power supplies is crucial for ensuring that electronic devices receive the correct voltage level to operate properly. Power supplies with adjustable output voltage allow users to tailor the voltage to the specific requirements of the device being powered. This is particularly important in applications where different voltages are needed for different components within the same system. Balance controls in audio mixers and stereo systems allow users to adjust the balance between the left and right channels for optimal stereo sound. This control is essential for achieving a balanced sound field and preventing sound from being skewed to one side. Balance controls work by adjusting the relative levels of the left and right audio channels to achieve the desired balance. Sensitivity controls in sensors and transducers are used to adjust the sensitivity of the device to the input signal. This is important for ensuring that the sensor or transducer can accurately detect and measure the desired signal. Sensitivity controls work by adjusting the gain or amplification of the signal received by the sensor or transducer. Calibration controls in measuring instruments are used to adjust the accuracy of the instrument by comparing its measurement readings to a known standard. Calibration controls allow users to correct any deviations in the instrument's measurement values and ensure accurate and precise results. These controls are particularly important in scientific, industrial, and medical applications where precise measurements are critical. Bias controls in electronic circuits are used to establish a predetermined operating point for the circuit components. Bias controls ensure that the circuit operates within its specified parameters and produces the desired output. Bias controls can be used to adjust the bias voltage or current in the circuit to achieve the desired operating conditions. Temperature controls in heaters and thermostats regulate the temperature of a space by controlling the heat output of the heater. These controls allow users to set and maintain a comfortable temperature in a room or building. Temperature controls can be adjusted to increase or decrease the heat output of the heater to achieve the desired temperature level. Controls play a crucial role in various electronic devices and systems by allowing users to adjust and control various parameters. Whether it is adjusting the volume in audio equipment, controlling the brightness of lights with dimmer switches, tuning into specific frequencies in radios, or adjusting the speed of motors. Controls are essential for achieving optimal performance and functionality in electronic devices. Potentiometers, also known as variable resistors, play a crucial role in voltage regulators by allowing for adjustable output voltages, fine-tuning of output voltages, current limiting, and voltage monitoring. These components provide flexibility and precision in regulating voltage levels in electronic circuits, making them essential in a wide range of applications. One of the key functions of potentiometers in voltage regulators is the ability to adjust the output voltage. By varying the resistance of the potentiometer, the output voltage of the regulator can be changed to a desired level. This feature is particularly useful in situations where the input voltage may vary or where specific voltage levels are required for different components in a circuit. The adjustable output voltage capability provided by potentiometers allows for increased flexibility and versatility in voltage regulation. In addition to adjusting the output voltage, potentiometers can also be used for fine-tuning the output voltage of a voltage regulator. By making small changes to the resistance of the potentiometer, precise adjustments can be made to the output voltage. This fine-tuning capability is essential in applications where a high level of precision in voltage regulation is required. Potentiometers enable engineers to make minute adjustments to ensure that the output voltage meets the exact specifications of the circuit. Furthermore, potentiometers are often used in voltage regulators to implement current-limiting functionality. In some circuits, it is necessary to protect against overcurrent conditions, which can damage components or lead to system failures. By incorporating current-limiting circuits with potentiometers, the current limit threshold can be set to a specific level. This allows for controlled regulation of the output current, ensuring that the circuit operates within safe limits even under varying load conditions. The ability to adjust the current limit threshold with potentiometers provides an additional layer of protection in voltage regulators. Potentiometers can also be utilized in voltage monitoring circuits within voltage regulators. By adjusting the potentiometer, the voltage threshold at which certain actions are triggered, such as shutting down the regulator, can be set. This feature is critical for ensuring the safety and reliability of the circuit by monitoring voltage levels and responding appropriately to any deviations from the specified range. Potentiometers enable engineers to customize the voltage monitoring parameters to suit the specific requirements of the application, enhancing the overall performance and efficiency of the voltage regulator. In conclusion, potentiometers play a vital role in voltage regulators by providing adjustable output voltages, fine-tuning capabilities, current-limiting functionality, and voltage monitoring capabilities. These components offer flexibility, precision, and protection in regulating voltage levels in electronic circuits, making them indispensable in various applications. By incorporating potentiometers into voltage regulators, engineers can optimize the performance and reliability of their circuits, ensuring that they operate efficiently and safely under different operating conditions. Thanks for your participation in this Majestic Mind Matters University Basic Applied Electronics Information session titled Introduction to the Potentiometer, ASHE.